I see more people stumble in. Here's something that I decided. I do have a question mark there, but I pretty much like this idea, unless anybody has very strong objections. I want to have a quiz tomorrow. 10-3, 10-6, 10-7. I want to do it tomorrow so that I can give it back to you on Thursday so you can look it over the weekend. Next week is going to be jam-packed. Yes, next week. Well, this Thursday is the first day of review for the final. Next Monday's a holiday. So next Tuesday is the second day of review for the final. And then the final is going to be the following 2 days. I think the first day is going to be no calculator part 1, and the second day is going to be you can use a calculator part 2. You guys all with me? I'm not going to try to shove a final into an hour and 20 minutes. You don't want me to. That would be horrific. So I'm not going to do it. Is anybody completely, horribly opposed to this idea? Quiz tomorrow? You are? What grounds? What grounds? You just don't like it? Or is there a good... You don't like it? Alright, let's do that. Anybody else? I'm sorry, hold on. Anybody else vehemently opposed to a quiz tomorrow? Perfect. We have a quiz tomorrow. Are you vehemently opposed to that idea? There's a decent reason why I shouldn't do it. No, okay. So we have a quiz tomorrow. This is, if I remember correctly, this is polar and this is parametric. Yes? And the polar stuff is old news. It's repackaged basic trig. Now I know if I say that, there's more complicated problems. I understand this. But fundamentally, the conversion formulas are just repackaged old trig. And then parametric is the TXY table to graph it and then try to eliminate the T, yes? Are you guys with me? Very anti-British. We're trying to eliminate that T, so throw it all in the harbor. Jeff, this is not history class. I'm sorry. Okay. Somebody had a question. I'm going to do a problem like number 12 in section 10.3. So let me show you what that was. This one. This one is sneakily tricky. So I'm going to create a problem like it. Okay. Okay. Does anyone right now know what the first step should be when I get a problem like this? Convert -7, now we get -1 to polar coordinates. What's the first thing I should do? First thing I should consider?
R squared equals R squared.
No. That's the first thing I'll do to move in the direction of making a polar. There's one thing I should do right now, just to ground myself for later. Something related to the angle that I'm going to get.
Which quadrant?
What quadrant? So I don't have to graph it, not beautifully. But I just have to think, what quadrant is this point in?
3.
Yeah, it's in 3. It's over here. So you can graph new ones, but all that matters is it's quadrant 3. So as we do this, when we try to solve for theta, we have to make certain that the answer we get is in quadrant 3. Okay, maybe. Now hit me. So that's the first thing you should do, is what quadrant am I in? When I'm given a rectangular, part of polar is getting r and the other part is getting theta. And why is theta such a tricky dude? Because how do I get theta? I take an inverse tangent. Can inverse tangent give me all the angles it might be? No, where does inverse tangent live? Yes, first and fourth, from negative pi over 2 to pi over 2. So it can't give me quadrant 3. Okay, so we'll worry about that when we get to it. So I know I'm in quadrant 3. So now hit me with the steps. How do I get R? How do I get R? What's R squared? You just started saying it earlier. What's R squared? Yeah, 49 plus 1. So R is the square root of 50. Now, can somebody please simplify square root of 50? This needs to be second nature. It's like if you get the answer as 6/8, it's second nature to you to reduce it to 3/4. Yes? Some of you guys don't even think of it. You're like, well, of course it's 3/4. What do you mean? Square root of 50. Second nature. Oh shit, I can simplify that. Just like 6/8. How do I simplify square root of 50? Yeah, the square root of 50. That's Jeff. It is square root of 50. Square root of 25 times square root of 2. So 5 rad 2. That's R. Now, how do I get theta? What equation can I set up related to theta? And it comes from the basic idea of tangent, right? What's tangent theta in general? This is old shit. We've known this is true since that first day when we made all the 6 ratios we could make. And I know what y and x are. What do I get? What are y and x? Yeah, the negatives cancel. Is that cool? So how do I get theta? Now, real quick. Yes, you take the inverse tangent, right? Can somebody tell me what quadrant this theta is in? This theta. What quadrant is it in? Remind me, inverse tangent goes from what to what? Negative pi over 2 to pi over 2, yes? Fourth and first. So which one of those two is that angle in? And how would you know? Well, is it positive or negative? The output to tangent. In this equation we just wrote, is it positive or negative? It's positive. So what quadrant? Is it the fourth quadrant or the first quadrant? First quadrant. Okay, beautiful. Let me stop for a minute. Are you guys at all with me? These are the considerations. I almost said these are the days we're on. These are the considerations when you're doing an inverse tangent. We know from the beginning, where must our angle end up? Third quadrant. We know from the beginning our angle has to be the third quadrant. So when we're about to solve for theta, I've got theta, there it is. But is that the right angle for the problem? No. Because where's that angle? First quadrant. So listen, so our angle's in the first quadrant, correct? How do I get it into the third quadrant? How do I get a reference angle? What would I do to this angle to get it to go into the third quadrant? How far do I want it to turn? Sorry? No? No, I mean, okay, it's going to end up more than pi. How far do I want it to turn? How far would I turn that thing? By pi, by 180 degrees, by pi, yes? So what is the actual answer then? It's this plus pi. That's where things get trippy when I have a inverse tangent that's like a decimal. It's not something we're supposed to know like rad 3. We're supposed to know inverse tangent of rad 3. I should be able to figure out that angle. This one is just some angle. I don't know. The angle that makes tangent 1/7. What angle is that? I don't know. But it would be in the first quadrant. Could that possibly be the answer to this question? No, because our angle has to be, like we said, our angle has to be in the third quadrant. Because this point is in the third quadrant. So if I stopped here, that would give me the point 7, 1. You understand? Oh, what's up? You guys all right?
Is this a homework question?
No.
Oh.
This is like 10.3, number 12.
Okay.
Yep. Did everybody understand what I just said? If I left it before I add pi to it, if I just stopped here, that's in the first quadrant, that would give me the point 7, 1. But I'm supposed to get the point -7, -1. Well, that's exactly 180 degrees away. That's exactly pi away. So I just add pi to it. Any other questions from homework? And just so you know, a question could be, hey Jeff, man, that made no sense. Could you do another problem and try to make sense this time? That could be another, no, don't say it like that, right? That would hurt me, I'm just a human, I'm a little math boy. But your question could be, hey man, could you help me out? That didn't really make a lot of sense. Could you try again? Nothing wrong with that question, yes? Any other questions? More on this one? Anything else from homework you guys are doing? Okay. Just in case, I think a few people came in after this very exciting announcement. Quiz tomorrow, 10-3, 10-6, 10-7. That way I can get it back to you graded by Thursday, and you can have it to look at over the weekend. What's happening in our immediate future? Next Monday's a holiday. This Thursday and next Tuesday is review for the final. That's right. I need to get the practice final to you. I'll get it to you tomorrow. Practice final will be given out tomorrow. Bless you. So next Monday's a holiday. This Thursday and next Tuesday, review for the final. I'll give a practice final tomorrow. And then the final is, of course, on next Wednesday and Thursday. This will be no calculator part 1. This will be calculator cool part 2. Yes.
So no calculator for part 1. Will we be receiving both parts at the same time?
Nope, obviously not, because they're on 2 different days. So
Oh, okay.
I can't give it to you on Wednesday, give you time to look at the answers and then come back. Yeah. Is that cool? At least this way, the terrible thing about the test I do when I have a part 1 and part 2 in the same day is you can't see the whole thing, so you don't really know how to apportion your time. So I was trying to tell you when you should be done with part 1. This at least is completely contained. You got all day, not all day. You got the whole class Wednesday to do the first part. You got the whole day the next day to do the second part. There's no weird, how much time should I give myself? You'll see everything you need for that day, all at that time. Any questions on that or concerns about this? Yes?
For the no calculated part, I mean, on the practice final, I'm sure it's gonna show us some answers, but is there anything that like we should know how to like do for the no calculated part that can help us?
Well, all right, here's some example problems I can give you on the no calc part. Obviously stuff like the sine of 45 degrees, right? Or even the sine of 210 degrees. I don't want a calculator for that because I get decimal answers and I'm like, Are you with me? So like, trig related to angles that you're supposed to know. So I don't want a calculator for you. I want to make sure that you actually know it, right? And then I can put stuff on there like anything that you don't need a calculator for, like, what else, Jeff? Obviously, I'm not going to put a lot of cosines on there on the part 1. That's going to be on part 2 because that's calculator heavy. Yes, but I could put stuff like factoring on there, some basic factoring. I mean, I could put anything you just don't need a calculator for. And then you guys are like, I disagree with you on what to need a calculator for. I'm like, no, it's too bad. But yeah, Wednesday I'm going to try. I wouldn't give you, more than likely I would put a lot of factoring stuff on Thursday because it is nice to have the calculator help you factor if I give you bigger numbers or whatever. Yes? I don't know what else to tell you. Yeah. Any other questions about what's happening in the near future? Okay. Okay. So let's do this. Anything else from homework or anything? Any other questions? Homework. Does anyone need, where'd that one go? Here it is. Someone need either this guy, partial fractions and system of equations. Anybody need that one? Does anyone need this guy? This is the one we got into yesterday. Okay. Everybody else good? You need one? Okay. Let me leave one up here so you guys can see what it is. Let me know if you need one of these. We gotta finish this worksheet out. Okay. So, all right. Let me do a quick example, and then I want you guys to do the problems on that sheet. If A is and B is how big is A? Careful. 3 by 2. Rows by columns. So how big is B? 1 by 3. Good. Is that cool? You guys with me? Can I do, is it possible to do A times B? So underneath you could put A is 3 by 2. B is 1 by 3. What about what I just wrote tells me I cannot do that multiplication? The inner ones don't match. And don't lose track of the physical reality of why we look at that shit. There's always a shortcut way to look at something, but students often lose touch with why it's true, and then you start to trust it less. How do I multiply? I take a row times a column. Shit. There. So I would need, what does this 2 represent? Number of columns. Bam, bam. So another way to look at it is the number of things in each row. Is that cool? If the number of things in this row doesn't match the number of things in this column, I can't multiply it. Does that make sense? I didn't ask you, does matrix multiplication make sense? Actually, this is what I just said makes sense. So it's physical. It is physical. I need you to see that. Could I do B times A? Could I do B times A? Yes. Because these match. Check. So how big would the answer be? 1 by 2. Now that's just neat. I'm not going to try to convince you to don't agree with me, but it is kind of neat. I could tell just by looking at how big the things are, I can tell if I could do it, and I can tell how big the answer is going to be. All right, so let's try B times A. So let me write B times A. This will be 219. Damn it, looks like 19. I'm sorry. And this will be 1, 2, 3, 4, 5, negative 1. Now, how does this work? Yeah, I take all these and all these. Yes? 2 times 1. Let me write this down. 2 times 1 plus 1 times 3 plus 9 times 5. Yes? And then it's going to be these and this one. So 2 times 2 plus 1 times 4 plus 9 times negative 1. So this will be 2 plus 3 plus 45. And this will be 4 plus 4 minus 9. So we're at the level, I need you to understand this. And again, I need you to take this the right way. In terms of matrices, we're at the same level as somebody who just learned how to draw the number 2, and we're about to get into how do you do 2 plus 3. Now, could I show them very easily what 2 plus 3 means physically? Yes, here's 2 toys, here's 3 toys. How many toys you got? Now, can I show you very easily physically what this means? No, that's going to be something you explore depending on which way you go in math. This is just setting down the basics of these objects. How do they interact? Let me ask you a different question. Could I do A plus B? Could I add these two together? What has to be true for me to be able to add 2 matrices together? The dimensions have to be exactly the same. So if one's 3 by 2, the other one would have to be 3 by 2. That's the only way I could add them or subtract them, right? Okay. So if you've got that handout, I think we haven't done this yet. If you guys could please do this problem here. This is the matrix multiplication side. Here's the examples up here. I want you to do these 2, if you can. Let me know if you need some help, or you can ask people near you if they look helpful. I'm hoping this color scheme I did helps. I don't know. If you'll notice, most of my handouts don't use a lot of color because color scares me. Hopefully that was helpful. me try to catch up to you guys. How big is A? Yeah, 2 by 3. How big is B? 2 by 2. So is this possible? No. If I turn this around, B is 2 by 2, A is 2 by 3. Is this possible? Yes. How big will the answer be? Okay. That's kind of nice, knowing ahead of time how many freaking numbers you're supposed to end up with. So you know if you're going in the right direction. So if I write, so A, B is not doable. So let me write, I have no idea why I chose to use like parentheses. Some books use parenthesis kind of things, and some, I normally use brackets. Just because that's how I was taught. So B times A, we can do, and you can see physically why it matches. So if I do this row by each column, what do we get in the first piece here? Yeah, 4 plus 9, 13. Is that cool? Are you guys with me? And then I move to the next column. And of course, what did I just do? The first row times the first column gives me the first row, first column element. First row times the second column gives me 2 plus 6, the first row, second column element. All right, so I can make this sound all official. Do you have to actually be able to say that as you do it? No. 2 times 4 plus 3 times 0, another 8. And then I move to the second row. So now all my answers are going to be in the second row. I'm going to move column by column and populate this dude. 2 plus 12, 1 plus 8, 4 plus nothing. How big is my answer? Exactly how big we predicted. Cool. Now, listen, it's a little insane. The amount of things you can do with this is absolutely insane. There's a whole field of mathematics that actually lead to real life shit that we could not do without matrices. It's silly. And we're just at the level of just, what the hell are they? What are these things, right? Okay. Is everybody cool with what's happening? Just in case you weren't here the other day, hopefully that multiplication idea made sense. It's sort of like distribution in a way, but not really. Up here, could I add these two together just to add another problem one? And what would I get? Exactly what you would hope, right? You just add each component together. What if I said to do this? Yeah, 3 minus 2, blah, 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 blah. Okay. So when I'm adding, subtracting, it's really nice. To add and subtract, they have to be exactly the same dimensions. Real quick, can you add x plus x? Of course. Can you add x plus x squared? No. Can you multiply x times x squared? Yes. So multiplication is always a little more relaxed. For matrices, they have to be exactly the same for me to be able to add them. For multiplication, they need just the inner things to match. They don't have to be exactly the same. It's a little more relaxed. So it kind of carries through a lot of things in mathematics where multiplication is a little less demanding than addition and subtraction. Okay, maybe. Do you have to ever remember what I just said? No, but it's a neat little thing to notice. Okay.
Can you go over how you did got the 8s?
Dear?
Yes.
Oh, okay. So if I take this row times, and we understand this times is defined in a weird way, so it'll be 2 times 1 plus 3 times 2. So 2 plus 6, 8.
Okay.
And then it'll be 2 times 4 plus 3 times 0. So 8 plus 0, another 8. Yes. This maybe hits 88. Okay. So again, it's a very weird way to define multiplication. And to be really honest, if you go further in mathematics, that's not the only way to define multiplication with matrices. So it's like, oh, good job. But this is the main way to multiply two matrices. Okay. So it just takes practice. That's really all this takes. It's a fundamental way that these objects interact. So you just have to practice it. Okay. So what we're going to focus on today is how do matrices help me? And I want to take a second. Can you remind me what the quicker way to do this is? What's the quick way to do that? Do I want to do long division? Synthetic. How do I set up the synthetic?
You put a positive 2 there.
Good, positive 2. And we did that because I didn't want to have to change the sign every time. I just changed it once. But what's really the main idea? Everything we're going to put down here now is just what?
1.
Well, I'm sure, but they're all going to just be numbers. They're going to be coefficients, right? I'm ignoring the variables because I don't need that information to do what I need. And then I get, bring the 1 down. Isn't a 1 nice to have down here? Why is a 1 kind of nice to have down here somewhere? Because then the multiplication is stupid easy, yes? A 0 would be even nice, but so it's 2, 7, 14, 7, 14, 20, 40, 41, blah, 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 blah. And then we can write what that means, and it didn't go in evenly. All that kind of crap, yes? I don't care about the next step after this. It's the fact that we went, holy shit, man. Long division has a lot of, holy shit, man. I keep writing these things, and they just keep canceling. Why would I write them if I know they're going to cancel? So then we just went, let's not do that. Let's just keep track of the coefficients. It's all that matters. So, we're about to do the same thing with systems of equations. So let me ask you this here. I'm going to start with, I'm kind of debating in my head right now as I talk to you. I'm going to start with a 2 by 2. And when I say that in terms of system of equations, that means 2 equations, 2 unknowns. Yeah, I think I will. We'll get there. Okay. So let's make a little 2 by 2 system of equations. Let's make this negative 2x plus 5y. What did I make these things? Oh yeah. That's negative 7. Okay. If you think about it for a second, you could probably guess what I used. But I want to do something remarkably similar to synthetic. Do you agree? Like, what would you do to solve this by, in fact, let's solve this by hand, and then I want to show you the analogy, because how did I teach you synthetic? We did long division, and then I did synthetic, and I showed you, oh, this thing we just got synthetically, look, it's right here in the long division. You can see it. So I want to kind of do the same thing here. What would tell you what to do here? Because what is our goal when I get a problem like this to solve? What's our goal? What's our first kind of?
Find x and y.
Find x and y. It's our overarching goal. What's our immediate way to try to get there? Because I can't do that.
I would put x by itself on the top one and then plug that in into the x on the bottom one, and then you.
So, real quick. I love that, because you could do substitution. But if I want to be able to scale this up. So what if I had x minus 3y plus z minus 4w equals 11? There's no nice way to substitute them, because I can't solve for 11. So what's the other way besides substitution? Yeah. So real quick, why would I multiply the top row by 2? What's the coefficient of x on the top? What's the coefficient of x on the top? What's the coefficient of x in the first equation? 1. And what's the coefficient of x on the second equation?
2.
So negative 2. So of course if I multiply the first one by 2, those numbers will cancel. If I had done this instead, Would our first step have been different?
No.
Nope. So what informs me about what to do? The numbers, the coefficients, yes? As long as my variables are lined up, the coefficients tell me what to do. Why is it really nice that I put this here? Why was that really nice of me to specifically put that there? What's really nice about this? What if I would have put a 5 here? What if I would have put a 5 here? Would it have been as easy? No. So what's really nice about what I put here? Why is it nice? Because there's a 1. So inherently, do you guys start to see 1 coefficients kick ass? And you kind of knew this before, but now I want to really make it clear. I want to really shove it in your face. A 1 coefficient kicks ass because I can make that become the other coefficient easy. Okay. So this just illustrates that it's not the letter that matters. As long as they're lined up, it's the numbers that matter. So let's do this. I'm going to call this equation 1, equation 2. If I multiply the first one by 2, and I add those together, what do I get? Yes? And then I can plug that in to get x. Are you with me? Okay. I'm going to show you what that looks like in matrix form. And the reason I didn't want to do a 2 by 2 is because the matrix form for a 2 by 2 system for 2 equations, 2 unknowns, is actually a little more work. But when we get to 3 by 3, it's about the same amount of work. And then when we get to 8 by 8, 8 letters, 8 equations. By hand, I would walk away. If I were you, I would just leave. I would just, no, good to know you, Jeff. I'm out. And I would go, you're right, you're right. But what I'm about to show you, that the freaking 8 letters, 8 equations shit would be easy. It would take a little longer, there'd be more writing, but it would not take anywhere near as long. So what I'm about to show you is what's called scalable. I don't care how big my system of equations gets. What I'm about to show you cuts the work required way the shit down. But when it's only 2 equations, 2 unknowns, it's kind of like, why would you even do a matrix? It's you don't need to. But I'm going to show you anyway, just because I want a small system to show you. So how do I make this into a matrix? Does anyone have any idea, considering I said this is roughly like synthetic division, where I just don't write the letters? Can somebody guess what this would look like as a matrix? Yeah. And I'm going to do this. What did that bar kind of represent? What do you think that bar represents? Where the equal sign is, yes? There's a couple different reasons why we do that, but for right now, it just kind of signifies to you where the variables stop. What does that first column represent in our matrix? What's special about the first column? What's it represent? The x's. Second column represents the y's, and the last column represents the answers. Right? Answers in this case, the equals to whatever, yes? Okay. Why did you guys tell me to multiply the first one by 2? That's such a weird thing to tell me. Why'd you tell me that weird shit? To cancel the other dude out. Alright, do you see in the matrix? Sorry, people next door. If there's anyone over there. Do you see in the matrix right here? Do you see a 1 somewhere? So here's what a matrix does for us. You're eventually going to realize what I'm saying. It takes that shit over there and makes it into a game of find my 1, make zeros. Find another 1, make zeros. Because what does it mean if I make a 0? So let's do it, and then I want to show you kind of a broader goal. Do you guys see I have 2 rows? I call this one row 1 because I'm silly that way, and that one I call row 2 because that's just silly. So tell me, what would you do to row 1? To start to kill a variable, what would you do? You just told me already. We already did it once. What would you do? Multiply by 2 and then add it to row 2. Okay, so I'm going to write exactly what you said. I'm going to double row 1 and add it to row 2. Let me see if you guys are cool with this, just to start with. I want to show you, the worst thing about matrices is if you keep rewriting the matrix more than you need to. All right, I'm going to do it the long ass way first. Why not? Just to really show you why that's kind of silly. So I'm going to double row 1. And if I add the rows together, where do I want to put the answer? All right, this is going to get weird. Which thing are we trying to kill? What do we kill over here? What are we trying to kill here? This guy, yes? So I want to put the answer in the second row. So I'm going to put the answer into row 2. So what is this plus this? 0. This plus this? This plus this? 1. I'm going to leave these alone. Yeah, I like this. Okay. I'm doing this in a different order than I normally do, but I think this will be good. I need you guys to see. Let me put this. Oh, this is kind of nice. Let me pretend like I planned this so I can move this up here. Do you guys see this in our matrix? There it is. And do you guys see this in our matrix? I'm sorry, this here. Do we see this in our matrix?
Yes.
Because isn't this 0x minus y equals 1? Isn't that negative y equals 1? Okay. Now, let me ask you, and just continue to go with me. There's a lot of little bits and pieces to explain the ultimate shortcut way to do this, because I want the matrix to make things quicker. Do I still need that first row to be double for any reason?
No.
What was the only reason I needed that first row to be doubled? To get rid of the negative 2. So to be really honest, is everybody with me so far? Has everybody got this? All right, I'm going to try to show you live a little bit of a shortcut. In fact, let me do this. So do I need this one doubled still? No. So let me just do 1/2 row 1. That's better because the numbers are smaller. Do you guys agree? So look what I could have done. Instead of this whole frickin' trip I just went on, yes? Has everybody got all this stuff here? I could have just done this. I could have just said 2 times row 1. I could put right next to this. What is 2 times each one of these? Because I don't need that forever. I just need it for a moment. Let me double each piece of this. 2 minus 2 is 0. Negative 6 plus 5 is negative 1. 8 minus 7 is 1. And then I just rewrite that. So what took us 4 steps, or 3 steps, is just really 1 step. So instead of rewriting the whole damn matrix every time, just put next to each thing what it becomes. You just need it for a second. Do you guys see what I'm saying? I really want you to kind of quickly buy into how matrices do help. Okay, I like some of you guys have a bemused face, which is good. It's better than a... Okay. Almost. So, what would I do next? In fact, what did we do next up here? Yeah, so if I take this row and I divide row 2 by negative 1, I get there. And what does this say? What's the second row say now? Yeah, 0x's, so y equals negative 1. Yes? Now, why is that 0 kick-ass? Why is that 0 so kick-ass? What does it mean? When I see a 0 in my matrix, what do we do? Sorry, you were about to say something, and I cut you off. You can do it. What do we do? What does that mean? If I have a 0 in my matrix, why is that so cool?
You got rid of the variable.
I got rid of a variable. That's the whole point. I want to kill variables. Right? We're little variable serial killers. We'll be right. So I already know what y is, yes? I don't know if anybody can see. Why does that first row still suck? Yeah, there's no zeros up here, yes? Do you guys see if I could kill him, I'll know x equals something? Do you guys see that? So if I ever kill something, that means I've got the other letter figured out, yes? Well, when we do 3 by 3, it'll be a little more, but how can I kill this negative 3? Yeah, if I take 3 times row 2 and add it to row 1, where do I want the answer to go? Row 1. So I keep overwriting a row because I keep getting better equations. Why is this equation better than that equation? Why is this equation better than that equation? Less unknowns. So what do I keep in my matrix at all times? The best information I know now. So I just overwrite the old shit with better shit. That's why I have to figure out where do I want to put the answer of what I'm doing right now. I want to put it in the first row. So if I triple row 2, that's still 0. That's 3. That's negative 3. Is everybody cool with what I'm doing when I write the little parentheses? You told me to triple row 2. I did. Add it to row 1. 0 plus 1 is 1. 3 minus 3 is 0. Negative 3 plus 4 is 1. Do we now know what x is? What does this say? What does this say? X plus 0, y. So x equals 1. And y equals negative 1. Solved. Now, what we just did was a little more work than if we would have just finished what we started up in the corner here, yes? Do you understand? So at the moment, it's okay if you're like, yep, this is what math people do, man. We were fine. Then you did this shit. So let me show you a 3 by 3 example. So I want to point something out. What is the most important number that I eventually want to have show up in certain places? What's the most important number? 0. What number is nice? 1. You guys see the difference there? Yes? A 1 is nice because then I can make it become whatever I need it to be. A 0 is crucial. I need to end with a bunch of zeros. In fact, let me see if you guys are cool with this. Let me do this. Oh shit. All right. I'm going to do this live. This will be exciting. Let me see if I can make a system of equations that actually works. Wouldn't that be nice? That'd be nice, Jeff. Can you try to do that? I'll try. Here, let me be nice to myself. Okay, that'll be nice. Blah, blah, blah. Okay, that would be 9, I believe. We're going to find out. Oh, Jesus. This should be exciting. What's that, Jeff? I don't know. -5? Yes. Okay. And then let's do... Sure, why not, Jeff? What are you doing to yourself? 16? Okay. Let's see. 9, okay. Yes, and then the last one's fine. Yes. Is the last one fine, Jeff? Yes, it is. Oh, all right, good. Can you guys take a moment and just write what that would look like as a matrix? That step, I'm hoping, feels a little bit like the synthetic division step. Just rewriting the important information. This is a major, you get it or you don't situation. So what's the first row look like?
1, 2, 9.
Okay, and then just keep going, right? Now listen. This is a really good situation. Can you imagine? I need you to really understand this. If you make one mistake as you do this, the whole thing goes to shit. Now, I don't say that to make you feel anxious. I say that to make you realize I know that all too well. Has Jeff ever done that? Oh, God, yeah. Oh, shit, yeah. But as opposed to some of my teachers, that either you got it right or you got it wrong, if you show me you understand what to do, I'll give you most of the credit. I totally get thinking to yourself, -3 minus 2 is 1. That's not right, but we're human. We're going to do that sometimes. And if you do that anywhere, the whole thing goes to shit. Because every piece relies on every other piece. I need you to understand what I'm saying. This could very easily get frustrating. Because all it takes is one little mistake. But what I'm grading you on is, do you know what to do? Do you know what to try to do? Right? If you make one little mistake, as long as you get all the way to some answer, your answer could look weird as shit if you make a mistake. You might not get any points off. I might just say, well, actually, -3 minus 2 is not 1. Right? And I'll say, I did exactly that before. Holy shit. Just yesterday. What is my goal here? What do I want this to end up looking like? This is something I normally start with, but I'm liking this. What do I need to end up with to show me I've got the answer? Can somebody figure that out? Yes, I need the first row to look like 1, 0, 0 number. What would that row be then? X equals number. And then the next row, I'd love it to be 0, 1, 0 number. And then 0, 0, 1 number. So do you start to see how, if I write this as a matrix, it becomes a game? Find a 1, make a 0. If you can't find a 1, there's other ways to make zeros. So I'll do another example like that in a minute. But if I see a 1 in a column, that kicks ass. So here's the way to do this when you're first starting out, which as far as I'm aware is all of us. Just pick a column and finish that column. If you start bouncing around making zeros, you're going to start to lose zeros as you try to make other zeros. It's like whack-a-mole. I made a 0. Oh shit, I made a 0. Oh shit, I made a 0. Oh shit. So pick a column, finish the column, move. What does that do for me? Do y'all agree if I make zeros here, if I add these to this first one, it's not going to screw with this? Because they're zeros. They're not going to do shit to this. So if I finish a column out, I'm never going to do shit to this guy. As I do shit over here, these are not going to mess with him. Maybe you guys get that. If I try to bounce around and make zeros in all these other places, I'm going to start to lose zeros I made already. And then frustration level goes up. So let's pick the first column here. So if I just focus on the first column, how would I make 0 show up here? Yeah, I take the first row and I multiply it by 3. Add it to the second row. Where do I want the answer to show up? Because of course I'm going to make a 0. Where do I want the 0 to show up? Here. No, that's my goal. So if I make a 0 in the first column, I better have it show up here, yes? So I'm going to take 3 times this, plus this, and overwrite this, because the equation I'm just about to make is going to be better. It's going to have 1 less unknown. So 3 times the first row. I just need that for a second. So I'm going to write what that is next to this, so I don't have to write the whole damn matrix out a billion times. So that's what makes this really suck. And now I do like I told myself. I'm going to add that. Those numbers I just made, I'm going to add it to the second row. Put the answer in the second row. Probably finish what you're writing there, Jeff. So let's see. 3 minus 3 is... Holy shit. -9 plus 1? -8. 6 plus 1, 7, and 27 minus 5, 22. Then the first row can stay the same. Why did I need these numbers? Do I need them forever? No, I just needed them for a second. That's why I'm not going to rewrite my whole matrix, because I'm not really, because I would triple the first row and then I would divide it by 3. Why would I do that shit? Let me push my luck here. You know, that's all you ever do, Jeff. That's a good point. To save us some time, I'm going to now do the next step. What's the next thing I want to have happen? Where in that first column, why would the first column not be done yet? We got a 0 here, yes? Where else do I want? I want the 2. I love it. That's exactly the way you should have said that. The 2, Jeff. What the shit? But I want to make sure everybody's really with me. I want this to be 1, 0, 0. Right now we got 1, 0, 2. Yes? So, I'm about to show you a little bit more of a shortcut. Are we done with these numbers? Yes. How do I kill the 2? Take the first row, multiply it by -2, add it to the third row, put the answer where? No? Third row. That's where I want the next 0 to show up, yes? Okay, so now I'm going to put underneath here, -2 times 1, -2 times -3, -2 times 2, -2 times 9. Now, if you don't like what I'm doing, you can do it different ways. You can write the matrix over and over and over again. I don't want to do that shit, but you could if you needed to. There's nothing wrong with that. So now I do. -2 plus 2 is the 0 we wanted. 6 minus 2, 4. -4 plus 5, 1. -18 plus 16, -2. Oh, this one came out nicer than I thought it would.
Whatever you say, Jeff.
I don't know, geez. All right. Why is that first column awesome? Because I've killed. Do you notice what we did? We killed a variable twice. Isn't that exactly how we would have done this by hand? We killed a letter twice. It's just easier. It makes it become a game instead of algebra drudgery. Not the funnest game in the world. I wouldn't pick this over like Outer Worlds 2 or something, but it's still a little more of a try to find a 1, make some zeros. Try to find a 1, make some zeros. Okay. Now, does anyone notice anything about the second column that I was really happy to see? I can't take credit for this happening. There's no way I could have thought this far ahead. So anyone see anything nice about the second row right now? Do you see 4 and -8? Can I make those easily cancel if I just change one of them? So do I have a 1 right now in the second column? Do I have a 1? No! I don't need a 1, because what's the more important thing? 1s are nice, 0s are necessary. 1s are nice, 0s are necessary. How can I make a 0 show up? In fact, what do I want the second column to look like? This. So how to make a 0 show up here? Multiply in by 2. So I'm going to do 2, row 3, plus row 2, and put the answer row 3 for now, yes. All right, so let me just write what I get here. So twice row 3. Twice row 3 plus row 2. So 0 plus 0 is 0. That's why you want to finish a column out so I don't lose my zeros. 0 plus 0 is 0. That's crazy. 8 minus 8 is 0. 2 plus 7 is 9. Oh, you're putting it in the wrong place, Jeff. You're doing a great job, Jeff. You're modeling things really nicely. Be quiet, Jeff. Let me try this again. You notice what I did wrong? I was putting the answer in the wrong place. I gotta look at my own thing. 0 plus 0 is 0. There we go. Put the answer into row 3. Negative 8 plus 8 is 0. 7 plus 2 is 9. 22 minus 4 is 18. How's everybody doing? You guys good? Okay. You're looking bemused over there, but we'll get there. Let me rewrite this again. Do you see we've already got one row that kicks so much ass? Do you see a row that kicks a lot of ass? Yes, okay. The last row kicks so much ass because it's only got one variable left. Now look at the first row. Okay. There are, all right, I'm going to show you this and then I'll point out some things we could have done. How do I kill this guy? Is it going to be as easy as it was to kill this guy? No. But what do? We just think of this as an LCD problem. Yes? If I multiply R1 by 8 and R2 by negative 3, they'll both become 24. Do you guys see that? So I like this. This had to happen if I just made a problem up out of nowhere. And I'm happy. I want to show you what's going to happen if I not only don't have a 1, but the stupid numbers don't act right. So the 8 and the 4 kick ass. Double 1, it makes a 0. Fantastic. Now I got 8 and 3. Damn it. But now I just multiply each one. I multiply them up to be the same number. So if I multiply, you guys look appropriately happy about this. If I multiply 8 times row 1 plus 3 times negative 3, so negative 3 times row 2, and I put the answer in row 1. Let's try this out. See if you guys are cool with what's about to. In fact, here I'll be nice to all of us. Let me pull what I'm doing over here. So 8 row 1 would be 8, negative 24, 16, 72. So instead of putting in little parentheses, I'm going to put it on the side here just so we can see it better. And then negative 3 times row 2 will be 0, 24, negative 21, negative 66. So all I did was I took row 1 times 8, kabam. Row 2 times negative 3, kabam. And then when I add these, let's see what we get. We get 8, 0, negative 5, and 6. Does my second row almost look, I'm not sorry, the second column, are my zeros where I wanted them to be? Yes, what's the only thing that's not quite right about the second column? Now the first column has an issue too, right? They don't have their 1s, but that's fine. The most important thing are zeros. So what I could do right now, and dear God don't, I could divide row 1 by 8. Do you want to do that? What would you make if you did that? Fractions. We never have to make fractions in a well, let me be careful. For the fractions we see in this class, for the matrices we see in this class, we never have to make fractions. Let me make sure everybody's really with me. This feels like a lot, but do you see how all we're doing is multiplying and adding, multiplying and adding? That's not very intensive, yes.
Is the 7 in row 2 an issue? Because shouldn't there be a 0 there?
There will be.
Oh, okay.
In fact, what did we do? What's the first thing we did? We got the first column to be right. Second column is now right, except there's supposed to be a 1, but 1s are nice, not necessary yet. What am I about to move to? Third column. What's really nice about the last row? What's the last row say? No x's plus no y's plus 9z's is 18. So what can I do to this? I can just divide by... Are you guys cool if I just do that? Anything you can do so you're not rewriting the whole matrix is good. Yes? Now, what really kicks ass in that third row now? I'm sorry, the third column. There's a 1. Not only that, but this is what I call, this 1 is now a laser. This 1 is a laser. What the shit do you mean, Jeff? If I double this and add it somewhere, are these gonna mess with my other zeros? No. So it's a laser. Whatever I do is gonna focus just on this shit. How do I use this to kill him? Multiplying by 5. Yes? So let me do this, just in the interest. Has everybody got where we are so far? You guys with me? Okay. Let me kind of clean this up a little bit. Let me write where we are now. All right, so now to kill the negative 5, what am I going to do? I'm going to take row 3 and, how do I kill the negative 5? Take row 3 and multiply by 5. Add it to row 1 and put the answer where? Row 1. I want the 0 to show up here, yes? So 5 times row 3 is 0, 0, 5, 10. 0, sorry, row 2, Jeff. Row 3, and you're fine. Don't look up there. Okay. 0 plus 8 is 8. 0 plus 0, 0. 5 minus 5, 0. 10 plus 6. Doesn't that look good now? Can I make a 1 show up here? How can I make a 1 show up here? Just, yeah, divide by 8. Okay. These are done now, right? I didn't need those, but just for a second, yes? How do I kill him? Take R3 and multiply by? Negative 7 R3 plus R2, R2, and put the answer in R2. So that'll be 0. So negative 7 times R3. I think this is the step that most of you guys probably won't like, but you can do this however you want to. 0 plus 0 is 0. 0 minus 8 is negative 8. Negative 7 plus 7 is 0. Negative 14 plus 22 is 8. And then the last row is still 0, 0, 1, 2. So what's the last thing I could do here? I can take row 1 and do what? Divide by 8. And I can take row 2 and divide it by? Negative 8. So row 1 divided by 8 would be 1, 0, 0, 2. Row 2 divided by 8 would be negative 8 would be 0, 1, 0, negative 1. 0, 0, 1, 2. And that's how I made the problem. I wrote that down for myself. As I wrote the equations, I just made sure that I was getting numbers using these. So I made the answer, and that's the right answer. Got a couple things. Was that kind of long?
Yes.
If I made, do you all agree that, let me see if you guys really can agree, if you've done enough of these problems. If I would have done this the way we did it at first, just keeping all the variables, it would have taken about the same amount of time to solve this. I don't know if you guys agree with me, but it's true. But if I add one more variable and one more equation, the amount of time it takes to do it with a matrix. What would I have done if I would have had a matrix that had one more, like if I had a matrix with, oh God, just to make shit up real quick. What can you do, Jeff? Sure. 1, 4, 3, 9, negative 1, 2, 1, 7, 2, 5, 0, 3, no, let's make that 9, 10, 11, negative 1, sure, blah, blah, blah. So now I've got x plus y plus z, 8x plus 2y plus 5z plus 6w equals 2, yes. If I do this as equations, not a matrix, that would take, screw it, man. I'd have to kill a letter 3 times, and then from the answers I got, I'd have to kill a letter twice, and then from those answers I got blah, 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 blah. Oh my God. But do you understand how now I just find a 1? Die, die, die. Move to the next column. Die, 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 die. Move to the next one. It doesn't make it take much longer at all. It's just one more 0 to make. I don't know if you might not be to a point where you can understand what I'm saying. But this is scalable. If you did 10 variables, 10 equations, not using a matrix, that would take a good hour just to do it. In a matrix, find a 1, make 0. Find a 1, make 0. 15 minutes at the most. So the amount of time you save with bigger systems of equations and matrices is insane. And how often do you get systems of equations in any STEM field? Oh, the flippin', are you kidding me? How many variables are involved in the weather? Holy shit, right? Have you guys ever heard about the butterfly flaps its wings and you get a monsoon on the other? I mean, the accumulation of various variables and their interactions, forget about it. You get all these equations with all these unknowns. So what do? We created computer programs, feed in a matrix that represents all your equations, and it spits out the answer, right? Because it's stupid easy. When I make a matrix, it's really, if anybody's done any computer programming at all, you can see this is a stupid, repeat this process, computer, until you get to this, you know.
I kind of made that connection earlier. I was thinking about bits and like numbers.
That kicks ass, that 1s and 0s. Yeah. These are turned on, these are turned off. Yeah. That's beautiful. So there's so many, not only is this easier by hand, once you get more practice with it, but this is very easy to make into a computer program. Every STEM field, you have a ton of variables. So on the other side of that, one sheet I gave you, is it this one? Yes. I have a worked out example where I explain what I'm doing all the way down. Right, so this is not a bad little dude to have sitting next to you as you're doing the homework. You can obviously have your notes from what we just did. Okay. So that finishes, if I remember correctly, I'm pretty sure that finishes chapter 11. Yes.
So this was 11.6.
This was 11.6. Did I forget to put it up there? Oh, there it is. Look at me. Sorry, I'm really bad about that. I just know shit. I don't know where it is in the book. I'm sorry. But yeah, I did. Look at me. I'm getting better. Finally now, I'm 53. I'm like, oh, this is how you teach. Oh, yeah. All right, so everybody up with what's happening this week, next week? What's happening tomorrow? That's immediately of importance. There's a quiz. Holy shit. And tomorrow I'll have the practice final for you guys.
So after the quiz, are we just gonna start the scene and
No,
reviewing?
after the quiz, we're going to talk about parabolas, ellipses, and circles and hyperbolas.
Oh, really?
Yeah, we got one more set of new stuff.
Oh, I thought the 11.6 was on.
Nope, there's chapter 12. It's on the homework sheet.
Okay.
Nirvana, her face just dropped a little bit. You're like, oh. But I'm not going to get too deep into that. It's the last thing. But I need to talk about it. So we'll talk about that tomorrow after the quiz, and that'll be the last bit of new stuff. Is tomorrow. Okay, I'll see y'all then.